So in the previous video we came up with the idea that time and space are not absolute, that they are affected by relative movement of things. And to get an understanding of this, we can carry out a thought experiment. We will consider firing a pulse of light at a mirror so that it reflects back to its starting point. And if every time it came back to its starting point we sent it out again, we could have the basics of a clock, which depends on the speed of light, which is fixed everywhere, so it gives us an accurate method of measuring time. Now imagine the girls on the platform with this pulse of light, but the pulse is watched by boys who pass in a high-speed train. And the girl and the boys measure the time it takes the pulse to reach the mirror and return. So we can synchronise things as the boy passes, and we send out the pulse. So from the boy's point of view, because they're moving sideways, the pulse appears to travel this longer distance. And that distance then, the total distance travelled would be 2s. So they will see time as different from the girl who the light is only having to travel 2h. And that difference in time is what we call time dilation. Because from the boy's point of view, the light is having to travel further, then they will see the time as they observe from the girl as being longer. Now their own experience of time will be identical. It's not that they feel that their time is passing more slowly or anything like that. It's just that time really does pass at a different rate when we're viewing something in a different reference frame. So for the boys in their own reference frame, everything would be normal, but when they're viewing what's happening for the girl in a different reference frame, then they'll see different measurements of time. So special relativity can be quite difficult to get a hold of when we first come across it. And what can make it even more complicated is the idea that it can turn around. The boys are in a moving reference frame from the point of the girls, but we could easily flip this and say, well, why is the girl's perspective any more important? Why is her reference frame any more important? We could say, well, let's imagine that the boys are in a stationary reference frame, and instead of the train moving past the girls right, on the platform is moving past the train and the train's stationary. That's what relativity allows, this idea that there's no absolute reference frame that we can take measurements from. And so in actual fact, if the girl was observing what's going on for the boys, she would see different times for them as well, because they're in a different reference frame.